So with the Light RTM process, as you can see, we have, it's basically a conventional A mold. So it's a composite mold. And then we also have, back here, we have a matched upper mold. And so we have an offset for the cavity thickness. In this case, what's our cavity thickness, Steve?
That's 2 4-ounce, SC40 4-ounce, so that'd be 8 ounces.
So how thick are we going to be in our cavity?
Close to a quarter.
About a quarter inch. So one of the things with the Light RTM process, contrasting to a traditional RTM process, is we have a lightweight upper, so it's easy to handle with a couple of people or a hoist. Instead of having clamps, we're using this flange detail here, where we're going to use full vacuum to clamp the molds together and keep them shut. So we'll have full vacuum between the green mushroom seal and the black wing seal, and then we'll have half vacuum in our part cavity. And then we have a resin runner around the inside of this green mushroom seal, where we're going to inject the resin at 2 different places at each end. The resin is going to run around and fill the cavity to our vent in the center. One of the other features about the flange detail is it's probably kind of hard to see on the video, but there's actually 2 hard stops here that will close against the mold flange, and that controls our cavity thickness. So we already have our mold loaded. Jordan's going to tell us in a little bit about the materials, but we're going to go ahead and close this up and get the injection started while we're continuing to talk about the process. So with Light RTM, you know, there's several different benefits. We have a controlled part thickness, but we can do several different, you know, we can do pretty high production parts, you know, compared to other closed mold processes like vacuum infusion. So we don't have any sealant tape or any consumables to use. We just close the mold, use the vacuum to clamp the ring, and we're ready to inject. So what they're hooking up now are the resin injection ports. So these are fittings from RTM North. We have the receivers on the mold, the 4104s, and then the double O-ring fittings that pop right in there. So Steve's hooking up the flange vacuum now. That's going to be our full vacuum side. And we have a dual vacuum pump from RTM North, where we can do half vacuum for the cavity and full vacuum for the perimeter. So now we're pulling vacuum on the outer flange. And this wing seal will make contact with the lower mold, and it'll pull the upper mold down until it hits the hard stops. Since we have a fixed cavity thickness, we know exactly how much resin needs to go in the part. We set the stroke counter for the resin amount, and we use the same amount of resin every time.
You're going to set it up for...
As Steve is explaining, so we have our high vac on our mold flange, and we have half vac on the inside. And we can do a drop test, and if we have communication between those 2 areas, we'll see it on our drop test. Our gauge will move, so we'll actually get high vac in the mold cavity.
Thank you, James. ChemTrend's focus for this year's show at CAMX is our mold primers, which is very important if you have composite tooling. Composite tooling, whether it is molded or machined, is going to have porosity. And if you're trying to pull a vacuum on that, you're not going to be able to get a good vacuum if you have air leaks inside your tool. So we recommend the use of a primer. We have a new primer, too, for very porous materials like 3D printed material and also low-density tooling board. And then finally on the mold here for RTM, our workhorse, Chemlease R&B.
Thanks, Russ. So as you see, we've already started the injection. So we have 2 injection ports, one at either end of the mold, and the resin is flowing around the resin runner. and into the cavity. We have our vacuum vent here in the center. It's connected to our vacuum bowl. So this will catch any excess resin that comes out. We shouldn't have much extra resin. And then we're connected to our pump on this side.
I'm Jordan from Vector Ply, Business Development Manager. Here to talk about needle ply. The actual parts, the upper and the lower is made out of this material. So we've got a wide range of products in needle ply family. The SE products is what we used here today. The main purpose of these products to be used in these tooling applications is for cosmetics and conformability. Today, the SE product is really the material of choice here. We do have other combinations of materials we do incorporate with knits and other materials. You can check those out at our booth at Vector Ply right across over here. We've got a lot of samples to hand out, but these are brand new products for us, new technology that we've been developing the last year or so.
As James mentioned, I'm Ashley Duncan with Polent, and you're attending a Light RTM demonstration, but I want to take a minute and just tell you a little bit about our materials and products that we use to build the tooling that we're using today. Polent has a full line of products for tooling construction, but I'm just going to touch on the few that we used for this process. Starting with our tooling gel coats, we used the 945 series gel coats that we have for tooling that offer good surface hardness with excellent polishing properties for high gloss retention. You know, I also want to add some of the benefits of using the OptiPlus system with exceptional dimensional control. We have very high glass content when we're infusing our tooling with this system. And then also I just want to point out too the TG requirements that we have. This system is in excess of 170 C, which can provide for a good thermal property retention over the life of the tool as well. Okay, so that's the tooling material. So now I want to introduce our new, this is a low profile RTM resin that we're demonstrating today. It's called our Polent A6125. As I mentioned, it's a low profile system. It's designed for excellent surface cosmetics for your finished part without the need for a barrier coat or skin coat. We do have some finished parts that are molded that you can see here on display with our 99F series gel coat and in image black. We can't gel coat here in the show hall, so Steve obliged us with making those in advance. So some of the benefits of this resin system is that it offers exceptional mechanical properties. It's a low viscosity resin. It's designed for closed mold processes. It's 100 centipoise resin, so ideal for good fiber wet out. Rapid cure development as well that you can see in your process. We're using 1.5% MEKP9 from United, and so we'll probably see a barcoal development and be ready to demold this in about an hour or so.
Yeah, so as you saw, we injected the part, it filled in about 6.5 minutes. We clamped the vent and the feed line. How many strokes did we put in, Don?
253.
Okay. Tell us a little bit about the equipment we're using today.
Yeah, well, thanks, James. Again, my name is Don Williams with Magnum Venus Products. Wanted to talk about a few features of our system this morning. This is a fully pneumatic system. It comes with recirculation. It has a mold pressure guard. The mold pressure guard is basically built into the system so that when the resin hits the flow front, it'll sense the back pressure. If the pressure gets too high, it can slow the pump down or cause it to completely stop until the pressure equalizes out in the parts, so you don't blow your vacuum seal or cause any destruction to your mold.